Welcome to this explainer. Okay, so we all kind of know the drill when it comes to shipping a regular package, right? Maybe you even know the basics of shipping a standard passenger car across the country. You put it in a container or load it onto a truck, and off it goes. Pretty simple. But what happens when you need to move a 30-ton concrete mixer, which, by the way, is essentially the weight of 5 adult elephants, or a massive fuel tanker, or a custom-built fire truck across the actual ocean? Well, we're leaving the world of standard dimensions way behind, and we're entering an extreme, incredibly high-stakes engineering adventure. Today, we're breaking down the technical logistics of special vehicle shipping overseas, and we're going to transform what looks like a total logistical nightmare into a pretty fascinating science.
Okay, let's dive right into this 5-step mission blueprint. First up is the extreme shipping challenge. Second, choosing your shipping vessel. Third, defeating rust and motion. Fourth is the engineering reality. And finally, step 5, clearing international red tape.
Starting with Section 1, the Extreme Shipping Challenge, Man versus Nature and Physics.
So the stark contrast between standard vehicle shipping and special vehicle shipping is just immense. When you ship a standard passenger vehicle, you're dealing with standard dimensions, a highly predictable weight distribution, and usually enclosed, safe transport. It's safe. But on the special vehicle side, it's a completely different battlefield. We're dealing with wildly non-standard dimensions, dangerously high centers of gravity, and incredibly sensitive hydraulic and mechanical components. Specialized machinery like fire trucks and fuel tankers, they literally have to survive hostile conditions that would absolutely destroy your standard sedan. Pulling this off demands a really deep, highly technical understanding of maritime logistics and structural integrity just to survive the trip.
Moving on to Section 2, choosing your shipping vessel, finding the right armor.
Now, what's really interesting about this slide is that choosing the vessel is the single most critical decision in the entire logistics chain. You basically have 3 paths, and they're dictated by the vehicle's drivability, its dimensions, and total weight. First, you've got row-row, or roll-on/roll-off. This is super cost-effective and best for drivable fleets. Think concrete mixers and fire trucks. The only real constraint here is the maximum ramp height and width. Then you have breakbulk. This is the only viable path for massive, non-drivable equipment like large tankers or oversized cranes, but it's entirely dependent on crane lifting capacity. And finally, flat racks. These are perfect for truck chassis or small trailers, provided their width doesn't exceed the actual rack limits.
Let's look just a little closer at the specific requirements and the risks of each of these methods. Row-row is brilliant because minimal handling really reduces the risk of structural damage, but it absolutely demands functioning steering and braking systems. I mean, the vehicle has to physically be driven onto the ship via a specialized ramp. But what if your equivalent can't be driven? Well, breakbulk is a totally different beast. Because these oversized vehicles are being lifted individually by port cranes or ship gear, you must have certified lifting points on the chassis. If you don't, the frame could warp under its own massive weight. Plus, you run a higher risk of exposure to the elements if it ends up stored on the weather deck. And flat racks? These come into play when a vehicle exceeds the limits of a standard 40-foot high-cube container but still fits the footprint of a container ship. Securing them is intense. It demands heavy-duty nylon webbings or heavy steel chains. Ultimately, before you finalize any of this, you have to verify your port's discharge capabilities. Not all ports have heavy lift cranes for breakbulk, and definitely not all of them have the ramp infrastructure for large-scale ro-ro vessels.
Which brings us to Section 3, defeating rust and motion, armor plating and lockdown.
30 to 45. I really want that number to sink in for a second. That is the number of days these precision-engineered machines must survive at sea. For over a month, they are subjected to a ruthless, highly corrosive saline maritime environment. Out there, the ocean is essentially a hostile entity that is constantly assaulting these machines.
To survive that 45-day assault, these vehicles require absolute anti-corrosion armor. Make no mistake, if this fails, the machine is ruined. The ocean air will absolutely destroy unprotected metal. High-end equipment, like the specialized machinery manufactured and found on cnspecialvehicle.com, features specialized paint and highly sensitive hydraulic cylinders that make this level of protection completely mandatory. We're talking about applying a thick, heavy layer of industrial-grade anti-rust wax, like Tectile, to all exposed metal surfaces. And for the hydraulics, you have to retract all the hydraulic rams and coat those exposed rods with specialized grease to prevent severe pitting and rust. But, rust is really only half the battle. The other half is motion. Moving parts have got to be locked down to prevent kinetic damage from the violent pitch, roll, and vibration of the vessel. This is a literal lockdown procedure. Step 1. Concrete mixer drums must be mechanically locked so they don't freely rotate from the ship's vibrations. Step 2.
Fire truck ladders and pump truck booms require secondary mechanical lashings totally beyond their standard transport locks. Step 3, as we just mentioned, retract all those hydraulic rams. And step 4, you've got to manage the fluids and power. Most carriers actually require fuel levels to be under a quarter tank, and batteries must be completely disconnected and insulated. For high-tech vehicles with complex ECUs, they'll even use a master kill switch. All of this fluid and battery management is strictly required to comply with the IMDG, or International Maritime Dangerous Goods Code.
All right, Section 4, the engineering reality, overcoming the laws of physics. In the special vehicle shipping industry, the word standard literally does not exist. Logistics managers have to rely on precise, highly technical GA, or general arrangement, drawings. And the main culprit driving all of this, the center of gravity. And this brilliantly illustrates the problem. Special vehicles, especially massive liquid or powder tankers, have a tremendously high center of gravity. This completely dictates the lashing angles required, especially when you're using a flat rack. If that center of gravity is off-center or exceptionally high, your standard tie-downs just won't work, and engineers are forced to design and build custom cradles just to prevent the vehicle from tipping and causing a full-blown maritime disaster.
Beyond the center of gravity, there are 3 more brilliant engineering hacks logistics teams use to survive this trip. First is ground clearance. Heavy-duty trailers or low-profile special vehicles often just can't handle steep row-row ramp angles. The solution? Blocking and bracing techniques to temporarily boost that clearance. Next up, overall dimensions. You must remove protruding mirrors, beacons, and exhaust stacks. If you don't, you risk accidental breakage, or worse, the shipping company will slap you with massive over-dimension surcharges just because your side mirror was sticking out an extra 2 inches. Finally, the shipping footprint. This is where smart engineering saves thousands of dollars. High-quality manufacturers design their equipment with modularity in mind. By utilizing modular designs, like, say, detaching ladders or railings on a powder tank trailer, you significantly reduce the total cubic meters, or CBM, which directly and drastically reduces your shipping cost.
So, we've defeated physics and the ocean, which brings us to Section 5, clearing international red tape, surviving the final boss, bureaucracy. People constantly ask, do I need to wash the vehicle before shipping? The answer is an absolute, non-negotiable yes. And we aren't talking about running it through a quick drive-through car wash. Most international maritime routes require vehicles to be entirely free of soil and debris to pass quarantine. If you want to avoid massive, expensive quarantine delays, a professional, high-pressure wash of the undercarriage and the wheel wells is a strict, mandatory pre-shipping requirement. Because honestly, navigating international customs for these machines requires way more than just a standard bill of lading. Here is your vital regulatory checklist, which is heavily informed by guidelines from the TT Club and Bureau Veritas. First, you need an MSDS, or Material Safety Data Sheet. This is required if your tanker contains any residual chemicals, or if your fire truck has specialized fire suppression foams. Next, cleanliness certificates. These are absolutely crucial for biosecurity, especially in places like Australia and New Zealand, verifying there is zero soil or organic matter trapped in the undercarriage or those mixer drums. Third, export licenses. Some heavy-duty off-road units are considered dual-use, meaning they could theoretically have military applications, requiring highly specific export permits. And finally, insurance. Because these are high-value, incredibly complex machines, standard coverage just isn't enough. All risks marine insurance is mandatory. It ensures that specialized machinery, like the incredibly expensive pumping system on a tanker, is fully covered if damaged. The paperwork is literally just as critical as the physical engineering. So, the crucial point to take away from all this source material is captured perfectly right here. The successful transport of specialized machinery is a triumph over physics, the elements, and international borders. It is a massive, highly coordinated battle. The next time you see a heavy-duty concrete mixer pouring a foundation, or a massive fire truck roaring down your street, take a second and ask yourself, how many unseen, extreme logistical battles against salt, rust, gravity, and international customs were fought just to deliver the heavy machinery that builds and protects our everyday world? It really makes you look at these incredible vehicles in a whole new light, doesn't it? Thanks for joining me on this explainer, and keep questioning how the world around you actually gets put together.